So let's begin with another example where we're looking at how to factor by grouping. Now, although we are focusing on factor by grouping, it's always important to look to see if there are any common factors amongst all four terms before you begin the grouping process. A lot of times you'll find one and it'll actually make the factoring process a little bit simpler if you can find the greatest common factor amongst the four terms and factor that out first. So if you look through k to the fifth minus k to the fourth minus 2k to the third plus 2k squared, there is a common factor that they all share. They all can be factored by k to the second power, right? They all have that in common. So we're going to go ahead and begin with that, all right? We're going to divide all terms by k squared, and hopefully this will pay off in the long term by giving us a little bit of an easier problem to deal with later on. So if we divide by k squared, that gives us k squared as the factor on the outside of the parentheses. And we can go ahead and reduce k to the fifth minus k squared will leave us with k to the third minus k to the fourth over k squared will be k squared minus 2k to the third all over k squared. That should give us 2k. And then we have plus 2k squared over k squared. K squared over k squared, a lot of times we'll say that these cancel. They simply just divide out. So we're left with just positive 2. Okay, now from here we can then focus on trying to factor by grouping, right? We no longer have any common factors amongst all four terms. So let's go ahead and group the two terms up right through here. One of the things I always like to do is whenever there's a coefficient, I like to keep the sign. So for example, the minus in front of the 2, that indicates that's a negative 2. So I like to keep the sign with the number so that if I ever need to factor out a negative, I know that that negative belongs to the 2. So we want to split the group right after the second term, which is k squared. Split it so that we can keep negative 2 with the group that's on the right side. Okay, so now I'm looking at this and I'm going to say, okay, k to the third minus k squared. Looks like they both have k squared in common again, right? So we're going to factor out a k squared from both of these terms. So we get k squared, and that will give us k minus 1. Okay. In addition to that, if I look at the second group, negative 2k plus 2, looks like the greatest common factor is 2. But a convention with factoring is that whenever you have a leading term that's negative, we're also going to factor by a negative. So not only are we factoring both terms by 2, we're going to factor out a negative 2. So we're going to divide both of these terms by negative 2. So that will be negative 2 comes out. That's going to leave us with k minus 1. Okay, now you know you've done factor by grouping correctly when you arrive at an expression that gives you the same inside of the parentheses. That's ultimately the goal, right? So if we end up with k minus 1 inside the first parenthesis, we also want to see k minus 1 in the second parenthesis. All right. Okay, so now I'm going to focus on rewriting this because now I notice that, hey, both of these terms also have k minus 1. So I have a new GCF, and that new GCF is going to be k minus 1. When I factor that out of the both terms, the leftovers, k squared minus 2, become the new expression. Okay, now I'm almost done, right? But there's something that needs to be brought down from the very beginning. An initial GCF that was factored out, which was the k squared, right? So we don't want to ignore that. I want to bring that down so that the final expression will read as k squared times k minus 1 times k squared minus 2. And this will be our final equivalent expression from the original polynomial.